Welcome to Willis Resilience TV, a channel that brings you the very latest news and coverage of an expedition to the South Pole by 19-year-old Parker Leoto.
Since the team landed in the Antarctic, we've been following their progress every step of the way. The first leg of the expedition focused on collecting much-needed data to aid climate change scientists. Now, Parker and polar guide Doug's resilience will be put to the test as they attempt to set a new world record.
More details on that and their progress to come shortly. We'll also be finding out why the Antarctic is such a crucial place for the study of climate change. And we speak to a former Royal Navy Admiral who, until recently, was tasked with securing the UK against the major threats that climate change presents.
Meanwhile, Parker and Doug have reached one of the toughest points of the expedition.
Tomorrow is going to be, there's a stretch through the mountains, which is the Leverett Glacier, and it's actually not that long. It's a few miles, but it's a big difference in altitude. In a few miles, it gets an additional 900 meters, or 700 to 800 meters.
Looks like a piece of cake. We'll have it done by noon.
I certainly hope so, because the whole expedition pretty much comes down to this glacier.
This is the crux.
Yep.
This is the crux, and we always said that.
Yep.
So we're broadcasting from the foyer of the Willis building in London. That was the outside. Now we're in the inside bit, which is nice and cozy.
Very warm. So yes, it's certainly warmer here than it is out in the Antarctic for the team, although if we were reporting from the Midwest of the United States, we wouldn't be able to say that. Temperatures not dissimilar to what the team are experiencing have hit those areas in addition to ice storms in the last week.
Yeah,
some
ice
extreme
storms,
weather.
snowstorms. South Dakota and Montana had the worst of it over the weekend. Minnesota with wind chill factor as low as minus 40 degrees.
Ouch.
So some pretty extreme weather conditions in the US of A. But at least those guys can go indoors. No such luck for our boys in the Antarctic. Parker and Doug, who have been skiing for 12 hours a day since they began their world record attempt last Friday at 8:55 a.m. UK time, which is 5 to 4 in the morning on the east coast of the States.
Remember, to set the record, Parker and Doug need to cover roughly 18 miles per day for 22 days. Right now, they are on their own. They're in the wilderness and they've had to separate from the truck and the other team members in order to cross a stretch of ice with crevasses too deep for the truck to pass. Some dangerous ground.
Yeah, in order for this to be a world record, they have to reach the South Pole unsupported. So the truck is simply following them to bring us fabulous pictures and to keep in touch with them just to make sure it's all going to plan. Before the separation, at the end of day 4, the guys had covered just over 13.5 miles, which was a tough day as they climbed 1,400 feet plus, skiing through deep, deep snow. And we have a pie chart that shows how Parker's typical 24-hour day breaks down. It is 24 hours sunlight, remember there. So when they are sleeping, they have to wear, I'm assuming, have to wear some masks to keep the light out. But there you go, Colleen. Look, they're on the move, as you said, for half the day, 12 hours. And it takes 2 hours to make camp and break camp, which means on an average day.
Very little sleep.
Well, it's kind of, if they plan it well and they have a good day, then they can get 8 hours in. But obviously, that can be a moving feast for the guys. And if they want to catch up a little bit of time, make some more mileage, then I guess they'll just take less sleep. But that is a typical day for Parker and Doug on their own as they move ever closer towards the South Pole.
And the guys are really working hard for this record. In fact, Parker has been complaining of a rash and back pain, so some physical challenges that they're enduring right now. Doug seems to be holding up okay. He is pain-free, and we're going to hear from them in a little while.
Yeah, we'll attempt to check in with them via satellite. And if not those guys, then one of the team on the truck that can bring us bang up to date. Don't forget to keep checking the website for further information and updates as well. Parker is in the middle of the race right now, but he's still very clear that the race is really a tool to reach out to the wider world and get people talking about climate change. He told us about this before he left.
It's not about testing myself personally, I don't think. It's not really about proving myself. It's not even about me at all, I don't think. I don't want this expedition to be about me. I don't want it to be about focusing on what personally I can or cannot do. This is something that, it's an expedition that we are trying to use to contribute to society. So there's really two parts to that, which is, first of all, we want to do our part to contribute to the scientific community. Obviously, when we do these research programs, they're very specific and they are a very small part of a much broader scientific effort. But still, it's part of what we're trying to do. It's a very important part of it. And the other thing is trying to completely change the way that we talk about climate science, the way that we communicate climate issues to the public. And the more that we can focus on the importance of the changes that we are seeing as a world today and the relevance of those to people all around the world, the better. Because then, as far as I'm concerned, we're talking about what's really important. Because whether or not I'm able to continue on day 15, whether I have sore feet or cold hands or a mildly frostbitten nose, grand scheme of things, doesn't matter at all. But we are trying to tell a story, and one that is personal and emotional, and one that people can relate to, hopefully, in terms of their own challenges and in terms of telling a story about climate change. And really what we're trying to do is to use the personal story as a mechanism so that it's really not the end game to talk about my frostbitten nose.
Parker certainly is a man who has dedicated himself to the cause of climate change awareness. Joining us in the studio now is another man who has experience of doing exactly the same. That's Rear Admiral Neil Morissetti, who's an ex-Royal Navy commander, who, Neil, had a role taking on security of food, water and energy around the UK. That's a role that we'll talk in more detail about later on. What do you make, first of all, of the challenge that Parker and Doug have set themselves in Antarctica?
I think I'd start with huge respect for what they're doing. Yeah. I think it's fascinating. I think it's really exciting. And I have to admit, I'm a bit jealous as well. I'm sure when we talk to him, the environment and the harshness and everything will come home. But what he's doing is really important work in the sense he is working hard to get a better understanding of the impact of a changing climate, how it's going to affect all of our lives, both today, tomorrow and in the future. But at the same time, he's making it relevant to everybody who's involved.
So you're jealous?
Yeah, I'm
You've
jealous.
got a bit of adventurer in you, Neil?
A little bit, yeah. You see, the sailor comes home to the sea and he sits down on his couch and he wants to be back at sea.
I'll tell you what, let's talk to Nathan in that time of the morning where we try and establish connections via satellite. And Nathan Hambrook-Skinner is just a communications director, isn't he, from Willis, who's
That's correct.
out there
Part
on
of
the
the team.
truck following Parker and Doug now. Nathan, checking you can hear us okay? Nathan, hi, it's Dan in the studio. Can you hear me? No, okay. Neil, let's come back to you, seeing as that didn't work, but you know how difficult it can be with those satellite connections. I'm sure your telephone conversations back home when you're away on HMS Invincible went down every now and again.
There are occasions when you're talking through a lot of static and noise to get your message home, but it's a funny old thing, when the message comes the other way, it comes crystal clear.
Yeah, I know. But we'll keep trying to establish those connections and chat with Nathan very shortly.
Now, you've been focusing on the role and some of the risks associated with climate change. Can you tell us about your recent role and your contributions there?
Yeah, so for about the last 3 or 4 years, I've worked first as the UK government's Climate and Energy Security Envoy, and then for most of this year, I've been William Hague, the Foreign Secretary's Special Representative for Climate Change. And what I've been trying to do is to talk not just in this country, but overseas, around the world, to governments, to policymakers, to the business community, and also to civil society, highlighting that the impact of a changing climate is something that's happening today, and it's something that doesn't just affect the environment and social issues, health issues, but also, importantly, it has potential to present risk to our economic growth, our prosperity, and our well-being through stability and lack of conflict around the world, or in fact, a danger of increasing conflict as a result of a changing climate. And we need to develop a resilience to be able to cope with that and manage those risks.
There's that word resilience.
Yes.
That is the core message that Willis wants to send. I'll tell you what, let's try once more to speak to Nathan. We do apologise, Neil. We'll come back to you very shortly. Nathan, can you hear us? Hello, Nathan.
Oh, hi.
Hi.
Yeah,
Oh, well, we might have given up on you if we couldn't get through at that stage. How are you, Nathan? Are you well?
Yeah, good, thanks. Sorry we couldn't get you Parker and Doug this morning. I mean, I don't know how much you've heard, but we've, basically the skiers have had to peel off from the truck. Basically, they're taking a bit of a shortcut. And we've had to stick to a very well GPS marked route. The skiers are hoping to sort of shave off a few kilometres by taking a bit of a shortcut. But it means that they're travelling over kind of an area which we know has crevasses, so it's too risky for the truck to follow them because we obviously weigh a lot more than them. Whereas the skiers can probably they can ski over these snow bridges over the crevasses. The truck probably wouldn't be able to make it. So we're just waiting for them. Hopefully we'll rendezvous later today, possibly tomorrow morning, depending on how they progress. I mean, we're maintaining contact with the satellite phones, and we're doing our calls we're doing our safety calls separately. But yeah, like I say, hopefully we'll rendezvous later today. Fingers crossed.
And Nathan, we've been hearing about some of the physical challenges that Parker has started to face. So what do you make of his physical condition as he set off on the race today?
His rash.
Yeah, I rash. Yeah. So I mean, we spoke to them. We've had probably just a little bit more contact than you have, really. I mean, we spoke to them obviously face to face yesterday morning. Parker looked to be quite tired, actually, to be honest. You know, that's not surprising, really, because it had pretty tough days, in particular getting up the Leverett Glacier. Yeah, I think the rash is causing him some pain and discomfort, really. It's obviously got the medical kit out every night to sort of tend to it. It means that he can't sort of ski in his normal style.
I think we might have lost connection there, Nathan. Yeah, gone. But we got the gist of what's happening now. Hopefully the guys in the truck will then rendezvous once again with Parker and Doug just to check that everything is okay. Neil, I don't know if you could hear any of that, but that's some of the regular updates we're getting from the guys in the truck. Just wonder if there's something that you can relate to, these sort of operating in conditions that most people would have no knowledge of.
I mean, I've never operated in conditions as extreme as that, but I think you can understand both the physical challenges, but also the mental challenges, particularly if something's hurting or scratching or itching that's making it, distracting you from what you're trying to achieve and the way you want to do it and the way you train to do it. But I suspect at the same time the training they've done will give them that capacity. And I'm afraid that where resilience comes out again in the sense of the ability to fight through that and progress. But it will become increasingly a mental challenge.
I guess because there are similarities. They're sort of stranded in the middle of nowhere, which isn't dissimilar to being out on a ship for months on end or in a submarine.
And I think the key thing is its environment. Whether you're here talking about the Antarctic or you're talking about the Atlantic in a storm or the Pacific or whatever, you are, in a sense, you're vulnerable to the environment. But you must also use the environment and the weather and to help you. But that's the challenge, and that's the piece that you've got to constantly be thinking about. What is the impact of this? How will it affect the mission? What he's trying to achieve, or what I would be trying to achieve? For example, in Invincible, could I fly my aircraft? If I can't fly my aircraft, can I support the guys we're supposed to be operating with? All those sort of challenges.
And it's even more remarkable that at the age of 19,
that's
this is what Parker's facing.
That I think is the most amazing thing. And you see what he's done since he's 50.
Yeah,
I mean, he's quite.
Trekking to the North Pole.
Does he have any time to go for a beer? But the huge amount that he has packed in so far, and I think this guy is going to be around for a long time, and he's going to be a very impressive person.
Yeah, we're lucky to have him, certainly. Do you like submarines?
I do.
See, I like submarines. You know what I like submarines best? Where I like them best? Crashing up through Arctic ice. Now, these are fantastic shots that we've acquired. And Neil, I want to get your take on this. This is in the Arctic. It is a US submarine called USS Connecticut, I believe. Now, the reason for them doing this is to aid research in that area. It's just phenomenal. I mean, first and foremost, it gives you an idea of the power of these things. But it's not unusual for the armed forces, I understand, to aid research and analysis.
No, I think we've always been involved in research analysis, going back hundreds of years. The Royal Navy is always, every 6 hours, recording the weather wherever they are, every ship.
Right.
And that all gets fed back here for the Royal Navy to United Kingdom, but for American Navy to the United States, etc., to build up our understanding and knowledge of weather and ultimately climate. We measure the ocean, we do scientific research. And this is a really, I mean, this is,
That's
apart from that's a
extraordinary.
fantastic picture.
Yeah.
It's a great example of how you can use the military skills and the military technology and their presence around the world to help build our research understanding. But at the same time, the military needs to be looking at what are the threats and challenges to the future. Today's operations must be the priority, but one of those headlights has got to be on full beam, looking to the longer term. And increasingly around the world, but certainly here, United Kingdom and America, and in European countries, the impact of a changing climate.
Yes.
What does it mean for global stability, risk of conflict? Where's it going to happen? Where could the military find themselves being involved? What equipment do they need? And how do they adapt their equipment to recognise resource shortages, for example, and the risks that if we continue to burn lots of fossil fuel, the damage we will be doing to
And
the
that's
environment.
exactly what we're going to be talking more about a little bit later
So
on.
hold that thought.
Yes.
We're going to come back to that in a few moments. Thanks for joining us, and Neil's going to stick around for our discussions later. But first, let's take a look at some of the latest footage sent back from the team in Antarctica.
I wasn't surprised. What are we? It's disappointing. 8546.358.
Yeah. Can I have my water?
What is it? It's right there.
Why is that disappointing?
Because we skied 35 kilometers today and actually only went 10 kilometers south.
10 nautical miles.
6 nautical miles.
6 nautical miles.
Yeah. That's, well, it's not actually disappointing. You know why it's not disappointing is because
We had to do that.
we had to do it. It was always part of the route. We knew we were going to have to not go straight. I'm not so used to it.
Camp 2.
Sorry.
That's all right, you can talk.
I'm not so used to it, but at the same time, we skied very, very far, total. And as soon as we hit the glacier, we're going straight south. And it's encouraging for me that we are able to do it, because that's more than what we need to do every day to get the record. Then again, we have no idea what's going to happen up there because the conditions so far have been absolutely spectacular. So we've taken advantage. But it does mean that we've done nearly 70 kilometers in 2 days. So I'm really happy with that. But today, the rash got a lot worse, like really painful, almost to the point I couldn't walk. That's why my legs are like this right now. Yeah.
When in doubt, air it out.
It was, I mean, I was walking, Doug compared my walking style to someone who had just been riding a horse, which I think is fair. But it's so painful. And ibuprofen helps a bit, but it's just like delaying the pain to later. And we need to find a way to just deal with it, because I can't do this 20 days in a row. I've tried putting powder on it yesterday. I don't know what is in the powder that Doug brought. It had some sort of chemical reaction or something, and I cried for like 15 minutes. It was so painful. And the worst part is, I'm going to have to do it again tonight, because it did get better afterwards.
What's the plan for tomorrow then?
Get up and ski some more.
Groundhog Day. It's supposed to be Sunday, day of rest, goddammit. Can't we just have a day off?
Yeah.
Day off?
Not on a speed record.
Okay.
But,
Yeah, what's going on in front of us, buddy?
well, we're at the foot of the Leverett Glacier. We just walked here from the Ross Ice Shelf. We've been on moving ice the whole time. Thank you. We've been on moving ice the whole time. So we've been on sort of a glacier, but we're just at the base of the path through the mountains that we have to take. And it's, we've risen probably 1,500 or 1,600 meters, which is around 4,500 to 5,000 feet, just in the last 2 days. But tomorrow is going to be, there's this stretch through there's a stretch through the mountains, which is the Leverett Glacier, and it's actually not that long. It's a few miles, but it's a big difference in altitude. In a few miles, it gets an additional 900 meters, or 700 to 800 meters.
Looks like a piece of cake. We'll have it done by noon.
I certainly hope so, because the whole expedition pretty much comes down to this glacier.
This is the crux.
Yeah.
This is the crux, and we always said that.
Yep.
Yeah, they get through this
wow.
part, plain sailing all the way to the South Pole. Well, joining Colleen, myself and Neil Morissetti in the studio is Mark Maslin, Professor of Climatology at the University College London. You were a guest on our first show last Monday, I believe, Mark. And that was the science leg of the expedition.
Yeah.
Parker is now on his way to hopefully setting a world record. What do you make of what they're doing now? Because they don't have the comfort of the truck as they did previously.
Oh, this is incredible. I mean, the idea that two young men are actually pitting themselves against probably some of the most inhospitable sort of weather and sort of environments you can think of. I wouldn't do it.
That's all. We'll cross Mark off the list for next year's expedition then. Well,
It's tough.
Neil would do it. He's actually
Would
quite
you?
jealous of all that.
I'm getting withdrawal symptoms. You're back from the sea, you want to get out on an adventure
Yeah.
again.
You're not spending too much time with the missus now, are you?
I'm just trying to get some time at home.
Now, the reason we've got you two guys with us on the sofa at this particular juncture is to discuss the serious side of climate change. Neil, until recently, if you just missed the opening of the show, was responsible for securing the UK against the threat of climate change, and we're talking about a worst case scenario here. Now, Mark, I know you've got a theory about when that worst case scenario is going to hit and how bad it's going to be.
Well, the key thing with the worst case scenario, it's really in our own hands. So if we get together as a global community and decide that we're going to limit carbon emissions and we're actually going to try to actually change things and become more sustainable, then we can change our future. And I think that's what people forget. The future is actually not written. We can actually change it. So if we go for a nice, green, sustainable, growing economy, we can actually limit perhaps climate change to about 2 degrees by the end of the century. However, if we don't, and we're just doing the business as usual, as we are now, then we can be looking at 4 or 6 degrees.
What is worst case scenario? What does that mean in real world terms?
I would say worst case scenario is we'll be looking at the end of the century of, say, 5 degrees warming on the planet. Now, that doesn't sound very much, but that would be at least twice in the poles. So that means a 12-degree warming in the Arctic and Antarctic. Most of the sea ice would have actually gone from the Arctic and round Antarctica. You're looking at, say, most of the snow melting from the Himalayas and from most mountain regions. You're looking also at sea level changes of up to a metre and a half by the end of the century.
Okay.
And I want to bring Neil into the conversation because of your role in securing us against some of the threats of climate change. What are the potential national security threats? I mean, how does this translate?
Well, it's usually what Maslin's talked about, the rising temperatures, the rising sea level, the increased acidity in the ocean because of more CO2 there. All of that can impact on people's land and their livelihood, their homes. They can lose their homes as the sea level comes up, particularly in the deltas, the low-lying areas where lots of people already live, and we're projecting more and more people to live on the coastline in mega cities in the next 50 to 100 years. If you've lost your land, where'd you go? Can you move within your own country? Or do you try and move to another country? Can you move at all? You might be trapped. All of that puts pressure. It starts to increase tension and the risk of insecurity and conflict. At the same time, if you've got a family to feed and your livelihood's gone because, for example, a 1 degree rise overnight, 1 degree centigrade rise overnight in temperature could knock off 5% of a rice shield. We've seen the effects of extreme weather events, very hot weather in Russia in 2010, the wheat harvest fails, at the same time as we've got wet weather in Canada and Australia. As a result, price of wheat goes up, the price of bread, a staple diet, goes up. It was one of the contributing factors to the Arab Spring and the tension there. That knocks on to us in the UK because we need energy. It comes from the Middle East. It's a global market. If there's instability, then there's volatility in prices. It starts to affect our economic growth. So we're talking about a real global issue. And whether it's 3, 4 or 5 degrees, it's going to be of a magnitude that we need to think about it and work to reduce those risks.
But you're advising governments. What are you telling them? What are some of the options that they can consider
Well, the first thing I'm telling you is there is no security solution to climate change. But if you don't address climate change, you risk increased insecurity and instability around the world. And because where climate change is going to have its...
Can you just elaborate on that?
Yeah, sure.
Because in my mind, I'm thinking martial law, anarchy, society just going wild.
If you look around the world at where the stresses are, food shortages, water shortages, health problems, demographic challenges, they're principally in a belt that runs north and south of the equator, from Meso-Central America, through Africa, India, and on into Asia. That's where climate change is going to have its greatest effect. That's where we've seen conflict in the past. Conflict often because societies and the governments don't have the resilience and the capacity to look after their citizens. We're going to make it more challenging if we don't address climate change. Those risks are going to increase, and therefore there's more instability. It may be because people are moving from one country to another and causing problems on borders. It may be because they're competing for resources, food or water. All of that is a challenge in that area.
Yes.
But then we live in a globalised world. And right through the middle of that belt run the world's trade routes.
Yes.
So it's supply chain, it's markets, it's raw materials.
Yes.
So it starts to affect all of us. If we don't have growth and prosperity, we start to get tension in society.
Cynics, skeptics might say this is just scaremongering. In my mind, this is kind of a disaster movie. You know, I can see Will Smith dealing with a raging mob that are desperate to get us food and water, and they're blaming the whole thing on climate change. Is it that severe in your...
I think you actually have to take the context of today, because we see the future as terrible. At this moment in time, 8 million children actually starve to death every year. That's the population of Greater London. 800 million people go to bed feeling hungry every night, and 1 billion people still do not have access to clean water. And we're looking at a future whereby we're going to make their weather, their food, their security much more sort of variable. And therefore what we need to do is not only develop and help those people to actually be lifted out of poverty, but also protect them against climate change. And I think we have to build that. So actually the disaster movie in the planet is now, and we need to actually deal with it, because we're very smart. We can if we want to.
But it's a complex challenge.
Yes.
You can't say that is a cause of conflict, that's a cause of poverty, or that isn't, or that, etc. It's all meshed in as one. And what it needs us to do, which is perhaps different from what we've done with other threats to society as a whole in the 20th century or before, is to work much more between governments, business community, civil society. You see mayors in cities developing their cities for many reasons, not just to tackle climate change, to have better health, to have better livelihoods, improved quality of living, and bringing that all together, but do it in a fashion which drives down those greenhouse gas emissions, drives down the risks posed by climate change.
So do the other key players, when it comes to climate change and global carbon emissions, have envoys, such as you were?
Yeah, each country will do it in a different fashion. Some countries use some of the military, my colleagues in the United States, for example, but also countries as they work to set the conditions for international negotiations on climate change under the UN auspices. My role was very much not to do negotiations, but to help set the conditions. Some people do that, some people do negotiating, and some people do both.
Can we talk about time frame? You mentioned the end of the century. Now, to some people, that is very close. To other people, it's years away. It's years away. How long do we have, in your opinion, and I'm going to get your take on this as well now, how long do we have to do nothing?
We have zero time to do nothing, because the problem that we have with the climate system is there's huge inertia in the system. So any of the emissions that we're putting into the atmosphere now won't warm the atmosphere for another 20 years. So what we're doing is we're mortgaging the future now. And so if we want to act, everything we now do now will actually make it much cheaper in the future.
But if we were to have another expedition, Willis sponsored,
Of course.
God willing, yeah, in 5 years' time, would you be sat here saying the same thing, or would you then be saying it's too late?
I don't think it's ever too late.
Okay.
Okay, you cannot go down that route. You have to remember we are an incredibly inventive species. If we get to that point where we think there is no return, then actually we'll start to build technology that can actually take CO2 out of the atmosphere. Scientists are already planning for the worst case scenario. Scientists, unfortunately, do not necessarily have the same trust in politicians as everybody else. And so we're already planning for the worst case scenario. And what is plan B?
So what is that? I mean, can you elaborate? What are the plans that would be in place for?
Well, some of the key plans are, firstly, if you have a power station, how do you actually capture the carbon dioxide as it comes out? We do this with sulfur dioxide already to stop acid rain. And so it's how do we actually stop the carbon dioxide getting into the atmosphere? Also, simple things like if we started to replant the forests that we've deforested around the world, you can start to suck out CO2 naturally. And then there are other chemical processes whereby we can start to pull out CO2 out of the atmosphere. And so there are contingencies. They're expensive compared with just mitigating.
And this is a hugely political issue, of course, and you've represented the government on this, in particular William Hague. What's your feeling with regards, not just the UK government, but other major players around the world and their governments, with a willingness to go forward? Because it has to be collective.
Yeah, I mean, I think 98% of the scientific community, or 97% is telling us this is happening. 80% of societies are recognising this is happening. The challenge that governments are facing is there's so many other things happening at the moment, and it's trying to understand priorities. And there is perhaps a tendency when people talk about events in 2050, 2080, 2100, to say we'll put that off, we'll manage that later. The reality, as Madeline said, is happening now. Extreme weather events, the impact of that has been felt. Floods in Thailand in 2011, Honda workers in Swindon had to go on a 3-day working week because parts couldn't come out. You couldn't get microchips in Orange County, California or Poland. It's affecting our economies. It's affecting people's health and their well-being today. But it's trying to understand how to do it. And I think the first thing we've got to do is stop talking about climate change as simply a niche issue that's really just an environmental one. It's a social, it's an economic, it's a health, but importantly it's an economic and a stability and security issue.
Okay.
We need to frame it in the fashion we frame other mainstream issues and look at the tools we use for risk analysis, risk management, and develop the resilience. And in doing so, we can then start to see the opportunities.
You touched on one of the issues that we dealt with yesterday, Mark, and I know you'll have something to say on this, but there's a huge economic burden that going to, say, renewable energy brings. There were some figures, I think, as far as the Climate Change Act in this country is concerned, which was drafted back in 2008. I think the report suggested that it was going to cost something in the region of £200 billion. Now, when you look at that figure in the face of these times of austerity, irrespective of what situation we find ourselves with regards to climate change, that's a massive pill to swallow for the people that are tightening their belts and continue to do so, although recovery is starting to come.
I don't think anyone denies there's some costs associated with this. I mean, Nick Stern did a report about the economic costs, 1 to 1.5% of GDP to act, 5 to 20% of GDP if you don't act. But more importantly,
over a much longer period of time, which I think people struggle with.
We have to evolve. Take energy generation in the United Kingdom.
Yeah.
Our power generation systems are old, they need to be renewed. Our grid is old, it doesn't have to be a cope with a two-way flow. We need to be much more energy efficient. That's an immediate saving if you're more energy efficient, whether you're a business or whether you're a home, lagging your houses, etc., using more energy efficient technology. And I suppose the analogy I would use is, if you had an old car and you went to the garage, you wouldn't say, give me another one of these 20-year-old bangers, would you? You'd say, give me a new car. Give me a new car that's more fuel efficient, is better on technology, is more advanced, and has the sustainability. Now, he may say that's going to cost you a bit more now.
A lot more.
It's not a lot more when you look at it. And the cost is coming down. The cost of photovoltaic has come down markedly. The cost of wind is coming down. These are technologies. Now, we have to get... There's ways of incentivising this. But these need to be intelligent incentives, so you don't just leave them there forever and a day. You draw down on them as the technology advances, and you look to the next phase.
But that is a huge barrier, isn't it? There's the cost of becoming greener. in these economies that have been struggling, Mark?
I don't think it is. I mean, I think what you have to do is you build win-win solutions. So you provide solutions to climate change, but also they deal with another problem, which may be air pollution, it may be energy security. So we're all quite happy to be beholden to Russian gas in our country, but we don't want to actually generate our own electricity through wind farms. And also you have to be very careful with this whole economic argument. During the late 70s and early 80s, the British government decided that North Sea oil and gas was essential to the UK. So they put in huge tax subsidies to actually incentivise the oil companies going out there. That was great for UK PLC, brought in huge amounts of income, but we subsidised it. So if we as a society say, actually, no, that's great, but now we need to move to an energy secure country whereby we generate most of ours from renewables, you just change the subsidies. And so the numbers are really naughty because it's, again, why change? It's about society and how we actually play with the tax and subsidy knobs compared with, say, using oil or gas.
And don't think, if you just stick to oil and gas, the price isn't going to go up. The demand for that is going up exponentially as society changes, population grows, the rate of growth, but also the change in lifestyles. That is only going to push, the price might go up and down a bit of a seesaw, but the direction of travel is only one way. Whereas when you've installed new technologies like solar, renewable and other means, then you're not vulnerable to those price spikes which can only affect your predicting how you can pay your bills or how your economic viability as a company.
Yes.
Well, speaking of solutions, right? Speaking of solutions, Parker and the team are out there doing what they consider their bit. They know that their contribution is just a small part of the overall scientific research, the foundation of the scientific research, but yet they still feel it's a very important role for young people to play.
Yeah. Yeah, and talking of that, we'll keep bang up to date with their progress. If you just thanks very much indeed for now, gents. If you're just tuning in, Parker and Doug, who are embarking on this unsupported world record trek, we hope, to the South Pole, are kind of on their own. They've been separated because of the conditions, the terrain, from the truck. So the truck is now waiting to rendezvous with those guys just to make sure that they're okay. Parker, of course, very aware of the threats that climate change poses to our planet, but however much you care about the environment, digging those ice cores in -30 is tough going.
How do you feel about this being the last hole? No more science after this?
Well, you know, I'm usually enthusiastic about science, but to be completely honest, in Antarctica, it's such a pain to dig a 2-meter hole in the ground so you can sample at every few centimeters all the way down to the bottom. Now, I'm excited because we managed to do the whole thing without compromising the program. You know, there's a lot of temptation, there are a lot of reasons to cut it short, and we didn't do that. We were delayed by 8 days, and we still managed to do every single sample, every single pit, and more. And I'm very, very happy about that. And that's why I'm excited that this is the last one, because it means that we've got that part of the program just nailed down, and it's going to be done in 2 hours. And I'm really, really happy about that. I'm just excited for the next part.
Tough, isn't it, out there?
Yeah.
That was during the science leg of the expedition, and this is exactly the kind of science that people like you and other climate change scientists around the world, it's the research and the analysis of these ice cores and the snow samples that are going to help.
I mean, it's incredibly important. Scientists need data, and for Parker to be out there collecting new data that we haven't had before, the problem is that we all feel that our contribution is important, but actually it's the weight. It's actually producing as much data as we can so we can actually feed it into the climate models to actually try and understand how quickly some of these impacts could occur.
I mean, we need more people like Parker, it seems, Neil.
I think we do. I mean, that science is fundamental for making a case for action. Taking Parker's data, putting it through the research process, applying that research, transferring it into a product that can be used by policymakers, by the business community, by civil society to make informed judgments as they manage the risks. But all of it must be underpinned by the facts and the science.
Neil, it's been a pleasure having you in. Thanks so much indeed. Mark, I know
Thank
you're
you.
going to stay with us for the next debate.
Of course, Parker is joining a great tradition of studying the polar regions, but to really understand why taking these ice cores is so important for understanding the changing climate, we sent our reporter Ash to the British Antarctic Survey.
Amundsen, Scott and Shackleton headed to Antarctica in search of adventure and the South Pole. The men and women who go there today encounter conditions just as difficult as those early trailblazers, but what they seek could have implications for us all. I met Dr. Robert Mulvaney, glaciologist at the British Antarctic Survey, to understand why Antarctica is so important to science.
Antarctica itself is a very critical part of the global climate system. So we do need to do research in Antarctica because it's just so critical to how our climate works. You get no melting in the polar regions and therefore the ice builds up year upon year upon year. As snow falls through the atmosphere, it collects all the material in the atmosphere, it collects some of the gases, it collects any aerosol in the atmosphere, but it also has some memory of the climate as well. So as the ice settles and gets compacted, it's remembering the climate and the atmosphere of the past. So by drilling into the ice, I'm able to drill back into the past and recreate what the climate and the atmosphere was doing through many thousands of years. Well, what we do is we take the water itself. So we take the ice, which is made up of water. Water is made up of hydrogen and oxygen molecules, H2O. And there are heavy and light isotopes of oxygen and heavy and light isotopes of hydrogen. Now, all the water that falls in central Antarctica comes from the surrounding oceans. It takes more energy to evaporate a heavy isotopic molecule from the ocean than it does a light isotope. So all we do in the lab here is we measure the ratio of the heavy to light isotopes of water, and where we see proportionately more of the heavy isotope, we know the climate must have been warmer. So all we are doing is measuring this ratio of heavy to light isotopes of the oxygen and hydrogen from water and relating those to temperature. And by doing that through time, we can build up a climate record. So that's where our climate comes from. In central Antarctica, there's about this much snowfall per year. So if we go down a few hundred metres, we're going back a few thousand years. If we go all the way down to the bed, because the layers get thinner and thinner and thinner as you get closer to the bottom, we're going back hundreds of thousands of years. And in central Antarctica, I was involved in a big project, a place called Dome C, where we drilled all the way through to the bed, 3,200 metres down, and that gave us 800,000 years of climate and atmosphere record.
So research in Antarctica can tell us about historical temperatures on the planet. But how is that useful to us today?
About 10% of the volume of a deep ice core is air. So we're able to take a piece of ice from the past, we put it in an enclosed container, we suck out all the modern air to create a vacuum, and then we release the air by crushing the ice inside that container. Once that air's out, we're able to measure it in our instruments, and we can measure what was actually in the atmosphere at any point in the past.
This ice, the area of this ice that we're looking at right now, was floating around in the atmosphere at the time of the Battle of Hastings.
Yeah, so they would have been breathing air with this level of carbon dioxide. In fact, they would have they would have been breathing this actual air. This is the real air.
So if we look at that record, over all that period of time, we can see a very close correlation between carbon dioxide and temperature. Now, all through that period of time, the lowest levels of carbon dioxide we see in the atmosphere are 180 parts per million. That's 180 molecules in every million molecules of air. And in a warm period, we see up to 280 parts per million. Today, we're close on 400 parts per million, so 120 parts per million higher than at any point we've seen in the last 800,000 years. Now, that increase began about 250 years ago at the beginning of the Industrial Revolution.
So Antarctica has been essential in helping us understand the link between CO2 and the climate. But why do we still need to go there now?
This area here, West Antarctica, during the last interglacial, this was probably one of the sources of the sea level rise, the 6 metres of sea level rise that was observed during that period, that warm period, 120,000 years ago. As the climate warms towards the late century, we're expecting increased flow from this area, which may add to sea level rise. So it's quite critical that we look at the surface mass balance and how fast the ice sheet is flowing in this area to try to understand how much ice can make its way into the ocean and add to sea level rise by the end of the century.
What are you going back to Antarctica to do now? What comes next for you? Are you based in the lab for the next couple of years, or will you be going back out on the ice?
No, I'm going back out on the ice next year. I'm particularly interested in an area called the Pine Island Glacial Basin. It's an area where, from satellites, it looks like the surface elevation of the ice is gradually lowering. We're not really sure whether this is because the ice has begun to accelerate towards the ocean, or whether it's a change in accumulation rate. I'll bring those back to the lab here, and what I'll be looking for is any evidence of a change in accumulation rate. If there's no change in accumulation rate and the surface is really starting to lower, then we can conclude that the ice is probably, the mass balance is moving towards ice being taken out to the ocean and melting.
Let's get more into the science, shall we, and the importance of Antarctica and the role that that plays in the study of climate change science in particular. Still with us is Mark Maslin, Professor of Climatology at University College London, but joining him now we have Becky Bryant, who is, I love this, an expert in icicles. Is that right, Becky, at Birkbeck College, also in London. And Rowan Douglas, also with us, who's chairman of Willis Research Network. Hi, Becky and Rowan. Go back to that VT, Becky. It just blows my mind, the idea that you can study bits of ice with air in them that date back 1,000 years. I mean, it's almost to the point that it's impossible to believe.
It is amazing, but if you think about how ice forms, you've got all these snow crystals and they gradually squish together. You can see how the air would get trapped, and it's amazing that they can extract it in that way in the lab. But it's brilliant because it tells us about the relationship between carbon dioxide and temperature over those amazing timescales, 800,000 years. Huge length of record there.
So the ice is almost like an archive.
Yes, very much so. Yeah. The 2 Mile Time Machine, I think somebody called a book once.
The
2 Mile Time Machine.
2 Mile Time Machine. Does it go down that far? Yeah. 2 miles?
Yeah, 3 kilometres.
Good Lord. Yeah, I don't think Parker could get down that far, could he?
Well, I think Parker could.
You're right. I mean,
no doubt he could manage
someone
it.
that you've met, you know him well.
I think he could do it with his bare hands.
Rowan, tell us the importance of Antarctica and link it, if you can, to the research that you guys do here at Willis.
Well, Antarctica is often called the canary in the cage, but it's fundamental partly because it gives us this incredibly long history of carbon dioxide and temperature, which gives people great confidence in the relationship between these the chemistry and climate and temperature. That's the first thing. But critically, the ecosystems are so delicate there that small changes in temperature in the environment give a very clear signal. And it allows us to sense what's happening at a very early stage, perhaps earlier than we could in what's called the mid-latitude, such as the UK or Japan or the United States. So it's a very important place, hard place to work in, but it's a key indicator. It's worth the struggle.
Yeah, we saw Parker struggling with some of those
I'm
scientific
sure he
experiments
was.
earlier, yeah.
Yeah, and maybe you can just talk a little bit more about your samples, some of the samples that you take and the type of experiments that have been carried out.
Yeah, so I personally haven't worked in Antarctica, but there's a huge range of things that people are doing down there. So obviously there's the ice cores that you saw on the video, and that gives us that long record. There's also a lot of glaciologists working in Antarctica trying to understand how the ice sheets and the glaciers that come off them work, because obviously how dynamic they are, how quickly they're going to change under future climate change, has huge impacts for sea level rise. So if we lost all the ice in Antarctica, which seems unlikely in the near term, 1 to 200 years, but if we lost all of it, that would be 60 metres of sea level rise globally. And if we lose the West Antarctic ice sheet, which seems more likely, that's 5 to 6 metres of sea level rise.
How much of these changes can you, looking at empirical studies, evidence, attribute to climate change, and how much of it is just natural? You know,
This world, for instance, has been changing ever since it came into existence.
Well, I think that's one of the things that we as paleoclimatologists do. We look at the past climate. And so we know some very important facts. So, for example, the eastern Antarctic ice sheet, the huge ice sheet which has 2 huge mountain ranges running through it, that's been stable for about 35 million years in much warmer conditions. So that's 60 metres of sea level locked up in that ice. We know that whatever we're going to do in the next 200 years, that's going to be stable. What we are worried about, because we do see in the past records, is that arm, the arm sticking out from Antarctica, which is the western Antarctic ice sheet, which is about 5 metres of ice locked up there. And we know that in previous warm periods, that has all melted. And so what we're looking at as glaciologists is to try and see how quickly is that ice melting. And the problem is that ice has an inertia. And people always think that we warm up the planet, the ice will melt. But if you think about it, if you take a hot cup of coffee and you put an ice cube and you put it in there, it doesn't instantly melt. It takes a long time for that heat to get in all the way to the middle of the ice cube and to actually melt the ice cube. And that's what we're doing to that western arm.
I like those analogies. Yeah. You could have come in here and blinded us with science, all three of you, but it's those little analogies that make it a lot easier to digest.
Yeah, and I think it's so interesting, Rowan, what your team of research networkers, the educational aspect of it and your researchers. Can you elaborate a little bit on how they're working with businesses to talk about what are the real implications of some of this change?
Well, a very significant proportion of the business that Willis has is related to Mother Nature smashing stuff, extreme events. It's hugely significant for our insurance business and our reinsurance business. So everyone's concerned about the frequency and severity, and of course the impact of extreme events from below, earthquakes, but most significantly from above, floods, windstorms, and the like. And much of the science we do is trying to get a much better handle on the location, frequency, severity of typhoons and floods, and what impact they will have on the built environment, on cities, on human systems, and of course on life, because that's the very heart of our business. Many of our clients, our insurers, are regulated by the financial system to tolerate 1 in 200 year extreme risk. While with that sort of level of tolerance, you can't just look at old claims records. You have now to go to science and modelling to get an understanding of what the world looks like at those incredible extreme events.
You've been involved in this field for some time. Are you getting a better handle on being able to predict?
We're getting well, in terms of the word prediction is challenging, because we get a much better handle on being able to understand the level of risk.
Right.
We can forecast hydrometeorological events quite successfully now up to about 2 weeks ahead. So two examples. The warning that we had for Hurricane Sandy, of a very unusual track, saved a lot of lives, I dare say, and quite a bit of property loss. And then just this last weekend here in the UK, we had the most severe storm surge in almost 60 years. Actually, there was very tragically some loss of life, but much less than it could have been, and limited loss of property. That was a huge success of science, engineering, public policy, and indeed insurance. It was a non-news story. It could have been a catastrophe.
Yes.
And so this area of where science and nature and capital are coming together is absolutely what we call the primary colours.
And there was better communication between the Met Office and the Environmental Agency, which made a big difference. Becky, I just wonder what kind of things that you've been teaching over the years and how that has shifted. I was speaking to a friend of mine who's a meteorologist and a weather presenter on the telly. She goes, well, the textbooks have changed immeasurably over the years, and they continue to change. It must be exciting, but also difficult for you, just to structure a lesson.
Well, yes. So I teach on Masters in Climate Change Management, and all of our students work during the day and study with us at night. So they are all absolutely spot on. They know their stuff.
And watching now.
And watching, yes.
Under instruction.
And watching all the news that comes out. So we have to be totally on top of it. And of course, the new assessment report just came out on the science. And in a way, a lot of the science hasn't changed. We still know that it could be very bad, as you heard earlier in the programme. But the emphases are changing. So people are thinking more about sea level, and they're thinking more about changes to the ocean, increasing acidity and that sort of thing. So it's really interesting, as the science evolves, new emphases come out and new things come out that we realise that we need to plan for and take steps to manage the risk of.
Yeah. And we seem to be getting our science lesson and our vocabulary lesson a lot this week. We are, as I understand, in an interglacial period. Can you explain that, and what does that mean for the future?
Well, so over the last 2 million years, we've had fluctuations between glacial periods when we've had ice a lot further south. So, for example, 500,000 years ago, there was an ice sheet that kind of hit Zone 6 in London. Obviously, Zone 6 wasn't there at the time. And you...
Travel car to the glacier.
Yeah, there's fantastic documentaries showing glaciers and tube stations next to each other. But so huge ice sheets during glacial periods was much, much colder, good 10 to 15 degrees colder globally. And then those melt because of changes in the sun coming in from outside, differences in the tilt of the Earth mean we get different amounts of sun. And then we get these interglacial periods, which are like at the present day. So we do still have ice, but it's restricted to the poles, and it's much warmer. And what's interesting in terms of future climate change is that all of our records from Antarctica show that the maximum concentration of carbon dioxide during interglacials is 280 parts per million. So we're in this huge experiment because we've never increased carbon dioxide during interglacials. We've only ever increased it during glacials.
See, and this is kind of the problem that I have with this, Mark. How old is the Earth as we know it?
3.5 billion.
How many years have you been able to study, research, analysis, empirical evidence?
For climate change, you could probably track it back about 100 years.
Now, how can you possibly, in that relatively short space of time, know with any great certainty, in order to provide the right kind of information to those that are so heavily involved in climate change policy and beyond, that it is having a detrimental, such a significant effect worldwide? And how does that relate to what's happening in Antarctica? I mean, do you understand what I'm saying? It's just the fact that there is, as Becky said, we're in kind of an experiment, which would suggest there's still an awful lot we don't know.
Oh, I would never disagree with you. As a scientist, there's huge amounts of things that we don't know. However, you have to realise that for the last 30-odd years, all the major countries in the world have thrown huge amounts of research money to understand this problem. I have got colleagues in almost every single country that are studying climate change. We have people like Becky who are looking at the paleoclimate, looking at to see what are the natural cycles. Is any of the warming that's occurring at the moment, is that natural or is that partly due to us? And we are starting to answer those questions. And the IPCC, the Intergovernmental Panel on Climate Change report, 2,500 pages, which is basically a doorstop, is just the summary of all the science published in the last 7 years.
But there's still some doubts over that report.
Well, I think...
Very few.
Just to...
I know it's a few, but those few people are being heard.
Just to track back on something that was said earlier, we have 800,000 years of record now of temperature and CO2 levels in the world. That's a remarkable length of time. Human beings have only existed for 200,000 years. So it's far beyond human beings, let alone civilization, which has been around for well under 10,000 years. That's the first thing. Secondly, the basic physics of the relationship between the chemistry of the climate and the temperature of the Earth were established 120 years ago. So you can be pretty clear about what the temperature of the Earth will be as you increase levels of CO2, greenhouse gases, including, of course, dominantly CO2. We're pretty clear, and the projections have been tracked now almost precisely for the last 30 years of where temperature is going with increasing in CO2, we can see where CO2 is heading in the next 50 years. That's pretty clear too. Energy policy, even with its uncertainties, we will certainly be having higher CO2. So actually, there are some uncertainties of exactly what the temperatures and extreme events regimes will be in regions, but the fundamentals the science debate is really over in terms of.
I'm warming up now as devil's advocate, and I'm gonna reference Al Gore's film that won an Oscar, I believe, back in sort of 2000, 2007, An Inconvenient Truth. And part of that film suggested, Becky, that the Arctic might have melted by now, or we'd have lost a lot more of the Arctic than we actually have. And there are some reports that I've read recently suggesting that there is more of the Arctic ice than we've ever had before. And it's those, well, I guess maybe activists would suggest that they're anomalies, but it's those occurrences that, you know, maybe fly in the face of climate change science that weaken the debate.
It's cherry picking. The one thing you have to remember about science, it is weight of evidence. If you give me one record and say, look, the world is changing, I'm going to say, well, not sure. But when you start putting all the science together, it's very easy to cherry pick one place and go, oh, look, this glacier is actually not retreating. Yeah, but what about all the others in the rest of the world?
And it's a great metaphor that's just been. So, since 2008, we've been in a global recession. We're just beginning to perhaps come out of it in many countries now. And no one would have denied we've been in an economic recession. And yet, you will find many companies, many individuals, even perhaps many countries, which have not been tracking at the same level of recession. Right. But no serious economist would say 4 or 5 years ago we're not in a global recession because company X in southeast London is doing very well. You have to look at the overall system and its trajectory to come up with a view around economics and business, as you would in terms of the physics of the world's climate system.
There is an argument that London has never really been in recession, for instance. Or has been in the same kind of recession as the rest of the...
Not in the same, but the world has been for a whole set of reasons. But there's going to be localities and individuals who have actually done probably quite well. Okay. And I think one of the challenges is we don't use the same sort of, dare I say it, common sense when it comes to issues around environment and science as we do in almost every other walk of life, which most of us find more, frankly, accessible.
I think there's also issues around scale. So there are some projections that suggest that the East Antarctic ice sheet will grow in the future because precipitation will increase. There's very low snowfall there at the moment. But actually, as Mark was saying earlier, we're not too worried about the East Antarctic ice sheet because we know it's not going anywhere. And the amount of growth is very small compared to what might happen to the West Antarctic ice sheet, which has the sea coming in at the bottom of it and is therefore much less stable. So I think people talk about effects as if they're really big, and actually they're not in the context of the whole thing.
And just going back quickly to Parker, their scientific study is in the West, obviously, so they're areas that I don't think have been studied before, which makes it even more pertinent.
Yeah, it's very important.
Yeah.
And what else is happening in Antarctica beyond climate science? Is it useful for other purposes in terms of academics and studies?
Well, so obviously there's the glaciology, which we've already touched on. There's also a lot of work around the edges where they've been drilling into the ocean sediments to try and get that longer term history to see what's natural and what's new. So that's important. And then, of course, there's a lot of biological work. So like Rowan was saying earlier about the Arctic being the canary in the cage, you've got these very, very fragile ecosystems where everything is meshed together exactly right within very tight climate constraints. And if anything changes, then the relationships between the different parts of the ecosystem can be disrupted. And of course, the poles are experiencing the climate change with greater intensity than...
Let's just round this up by talking a little bit more about Parker and what he represents. I know this is probably going to be important to you guys as well, because you're working in those fields of study, and in particular, you know, Becky, with those kids. I call them kids? They're not at all, are they?
No,
they probably are compared to me.
Mine are kids.
Yours are kids,
yeah,
okay,
mine
fine.
are definitely grown-ups.
But yeah, the role of Parker, Rowan, to help engage the youth of today, the younger generations in this very matter, and to, you know, not to maybe get too in depth into the science.
No, sure.
But
I'm glad you include us in the youth,
Well,
because we're engaged because of Parker. I mean,
Yeah.
we've been, you know, sponsoring quite a bit of research for the last 5 or 6 years, but actually it's Parker's story, Parker's journey, which has created this opportunity that brings us to be sharing this sofa here with you in the morning. He is mobilising a lot of involvement and engagement across the spectrum, from youth right up to early middle age like us, even late middle age like some of our viewers, no doubt.
Well,
so there we are. I mean, he's been the
be
catalyst.
careful, we'll get some complaints from people who don't believe they're late middle age now. And
or that they will
think
become
we're
middle aged.
directing
They
at them.
can't project that definitely, so you never know. They may not become middle aged.
Yeah.
But there we go. Hey, his story and the fact that he blends so much of, you know, really great young scientists. I mean, he's a truly impressive scientist at one end, to explorer, incredible communicator, organizer. I mean, he really is someone who people can aspire to and look up to.
And Becky, you probably echo those sentiments, I'd have thought, yeah. Pretty much. Yeah, good. Doesn't even need a word.
No, not really. I think
are you taking some of this stuff and teaching it to your students?
Oh, well, I have to say, Parker...
Are we on the curriculum yet?
Not yet, no, I have to say, but you have to be. What I find fantastic about universities and getting those young minds in is people like Parker step through the door and you have this new, energetic sort of a view of the world, and actually those are the people we need to engage, because it's going to be those future scientists, those future politicians and business leaders who are actually going to change the world. Well, let's be realistic. We've mucked it up, and we're going to have to leave it to that generation to try and actually pick up the pieces and actually move forward. And if we can give them a good basis, so perhaps an international agreement, and actually start some of that, it will help them. But again, Parker's inspiration is fantastic, because it will get my students out of bed and really inspired.
When he's back, we'll put him in touch, or come and give
Excellent.
you guys a chat. And I'll be his agent and take 20%. Thanks very much indeed, guys. Great to have you with us. So then, in tomorrow's show, we're bringing you the very latest news on Parker and Doug's world record attempt. So hopefully the truck, who haven't been able to follow them because of the danger of the crevasses, will be able to reconnect, make sure everything's okay, and Parker's rash has cleared up a little bit.
Yeah.
We'll have rash update tomorrow.
Oh, no. Poor kid. Also tomorrow in our climate change debate, we ask, how much is a bumblebee worth? Just join us tomorrow for the next installment of our exciting journey to the South Pole.